Hi everyone, welcome to Zero Robotics. My name is John Scharf. I used to be one of the former competitors in Spy Spear specifically, and our team over at Bach Academy actually happened to win nationals. And with me I have Ryan. Ryan, do you want to say a few things?
Yeah, I was former member of the Zero Robotics team at Bach as well. We both started in our middle school, uh, I believe our seventh grade years. Um, we have we started out with Zero Robotics, and both of us have continued into programming throughout the rest of our schooling, much as we could through high school. I now attend Florida Poly as a computer science student, and you?
Yeah, I currently attend University of Florida, hoping to get a major in computer science as well. So I guess we like to say we both know what we're talking about.
A bit of experience under our belt, so hopefully that can translate down and we can help some new students understand the subject.
Exactly, yeah. So here today, this is kind of just like an introductory lesson, kind of to get a feel around what you're going to be working with. Um, this is your IDE. This is where all the magic happens. This is where you pick up the blocks and put them into this loop over here, and you make the spear do stuff. It's very simple. Over here, you've got a few categories that you can look at. These are where you'll grab your blocks. So, for example, we have spears controls, and these are all blocks that you can use that relate to the spears, like gathering information about it of sorts. Here's your debug settings in case you wanted to print out anything to the console. Here are your variables, which we'll be covering extensively today. These are how you store information from anything from coordinates to tracking steps, so on and so forth. These are your logic statements. These will also be really important down the line when you want to try and compare values to each other. Here are your math functions, some of my least favorites, but here is where, if you want to try and do any advanced math, you can find them here. Any basic math. Here are your loops. These loops are, well, I don't know. What would you say about these loops, Ryan?
So, loops are going to be, depending on the way that your code is written, depending on what you're writing, depending on the intention of what your code is going to do, loops can be very useful. So, for example, the one that we see here, the repeat 10 times, if there's a certain object that you want to repeat so many times, you can change that value of 10 to any number. So, it could be useful if there's a specific set of things that you want to run uh, a specific amount of times within your overall code. These loops can be very important, but for our purposes right now, they're not going to be used for a little bit.
Right, they have a bit of a niche use to them, if you will.
And that will
And
be somewhat similar with our next topic of functions. These are, in this sense, functions are user created. So if there is a section of code that you want to have full control over, that you can just call upon one time and it'll run one time or however many times. You can create what is called a function. But again, same with the loops. These are going to be more, they're very important, but going to be used a bit more down the line.
right. So these will cover a bit more later down the line. And probably the most important to Spy Spears in general is the Spy Spears tab. Imagine that. These are where you'll have all the types of information that you can find in your game manual, to where you can figure out how to take pictures or use your mirror or figure out how much time you have in the light or dark zone, so on and so forth. But that's stuff that we'll cover down the line. But mainly what we're doing today is we are covering variables. So at its core, variables are this sort of box type of deal. And in this box, you can hold any sort of information that you want. You can hold numbers, letters, words, so on and so forth. But mainly all that variables are, it's just a single piece of data that is used to hold a single piece of data. But in order to use variables, you have to make sure that you actually set them up first. This is called initializing. So if you look over here, you'll see is what it's called an init page. This init page will take you over here, and you have this little weird looking block. and has global variables and inits on them. So I should probably cover the variable types first. That might be a good idea, right?
Yeah. So for the purposes of Zero Robotics, there are going to be two types of variables that we use. So there is an integer variable and a float variable. Integer variables are your whole numbers, so negative all the way up to positive, 0, 1, 2, 3, 4, so on. They're just whole numbers with no decimal point. A float will be your decimal point numbers. So if you have 1.2, 1.5, 0.5, or so on. That's really the only difference in the two here.
Yep. So anytime you really need to use decimals, this will be really useful when you start setting positions for your sphere. You'll always want to see about using floats. But anything else, I think you can probably get away with using integers. So another really important thing is naming them. This is on page 8 of your slideshow. Because the way C++, which is how this whole program runs kind of behind the scenes, the way C++ is set up, there are very specific rules as to what you can name your variable. I'll kind of just read some off that's on the slide, like you cannot use spaces or punctuations. So something like, say, something like this won't work, and it'll actually tell you because you're using an invalid character, the exclamation mark. So if I were to remove it, it would be fine. I just awfully misspelled that. Oh no. we're gonna ignore that. Anyways, so also another big thing is to not make variables with the same name, because that will get very complex very soon. And there are also a few keywords in C++ that are completely reserved for other things, such as int or switch, and you are not allowed to name variables those types. So right after that slide, there's a little bit of a quiz there. You can kind of test yourself to see if you can recognize which ones are valid and which ones are invalid. But for our case, we're going to go ahead and skip to slide 11, and we're going to take a look at declaring a variable. So go ahead.
As we move on to declaring a variable, I do want to point out the two different types of variable blocks within the ZR IDE. So we have these purple ones and we have these pink ones. So with the pink ones, those are often used when you have a variable that just has a singular value. With the purple ones, those are used with a variable that has multiple values within it. So as you see with the purple one, there is the length block. So think of, commonly you'll be using this for position. So within Zero Robotics, it's working in zero gravity, which means you are on a grid of a 3D grid of X, Y, and Z. So your points, a position, would have an X, a Y, and a Z. So you would use this purple block to set your X, Y, Z, given your length 3. And if you have direct points, so 1, 2, 3, 1, 4, 5, whatever as your XYZ coordinates, it can be an integer. Otherwise, say it's decimal, you would be using a float. Given that your sphere is moving, you want to be using a float, which lets you work with more precise values.
Mm-hmm. This is also what we call an array, this purple block, and this will also be something that we'll cover a bit more down the line. But it's just kind of good knowledge just to know that this exists in general. But anyways, today we're just going to be sticking with the purple or pink one. Nice. Pink one. We're going to be sticking with the pink one. So we're currently on page 12 at the moment. So we're going to take this variable block and we're going to put it in global variables. That way this will let anything else use this variable that we've made. And we're going to turn this variable, we're going to name it y. And we're going to go ahead and leave its value as 0 for now. So all that we did here, this is your bread and butter. This is initializing a variable that you can use in the main page over here. It's just taking a variable block, putting it in global variables, naming it, giving it an initial value, and you're done. So what we'll see when we go over to the main page is that now we can use these variable blocks here. So we're going to go ahead and grab this one here, and we're going to put it in our loop. And now, when we click this select drop-down menu, you'll see that our variable that we created previously is right here, ready for us to use. So we're going to go ahead and select that. Select. Jeez. We're going to get it. Oh, okay. We're going to go ahead and put 1.5. Man, it's been so long since I've done this. I'm going to go ahead and put 1.5 in here. And that's just setting our variable to a value. So now our variable y is equal to the value 1.5. That's all that this is saying. So currently we're going to go ahead and move on to page 14. And now is where we get to do some of the more fun stuff. Now we can see about trying to actually move the sphere itself. So we're going to go ahead and take this block here, the set position. This one is very straightforward. Jeez. But anyways, so these three values right here correspond to the x, y, and z value of your sphere. Z value is something that we won't really get too much into, since if this is middle school, you don't really deal in 3 dimensions, but like a lot of things, it's good to know that it exists. But now that we have this here, go ahead and move on to the next page here, and we're going to go over to our variables tab, and we're going to select this block here. This will let us actually use the value that we set previously. So we're going to go ahead and change this to y. And now we're going to take this and we're going to replace it with one of the zeros that's here. Now, geez, all that this is doing is just saying that now instead of this y position equaling 0, now it's going to equal what the y variable equals, which is 1.5. So it says there in your slide, but what should happen is that the satellite will now move along the y-axis, and it will stop at the y 1.5 position, because that's what the y variable is equal to. So here's our basic program. That's all we got here on the init page and on the main page. Now, once you put in all of your code and everything, we have to get to compiling and simulating. These are very important, as these will actually let you see what your sphere is doing. So we are currently on page 16, but you always start a program with compiling. Compiling basically takes all of the code. No way. Okay. Oh. No way. Okay. All right. This is a good learning moment. See, this is why you compile right here. So it says right here that y was not declared in the scope. Why? No way. Wait, did it work? Ryan, do you see anything here? It seems pretty straightforward, right? I followed the whole thing.
I see no issues. There shouldn't be any issues.
There shouldn't be. No way do we start our first video and there's already an error. See, okay. All right, we're all good. All right. See, this is a teachable moment. This is a teachable moment. When all else fails, reloading the page is always a good idea, because sometimes the compiler just does not like you and it just throws errors like this. But okay, like I was saying before that though,
working with programming, you will very often run into errors such as that. So whether or not, typically an error will always get thrown whenever there is a few different things. It could be an issue with your program that you wrote. It could be an issue with the compiler itself, just like a glitch. So if there is an error, normally whenever you look at that error where it says like error on page init line 2, So that's kind of trying to tell you where in your code the error is coming from. So what that does is it lets you go back and just kind of look for something that may be wrong.
Yeah. So
Writing a code and having an error thrown back is a huge part of programming, and it is something that you will run into all the time, even with the most basic of codes.
yeah, I should also point out that these errors here do have them as lines. We'll kind of address that a bit more once we finish our simulation and stuff. But there is an option that lets you see the actual code itself and what these blocks mean in C code. But we'll get to that a bit later. So, like I said before I got rudely interrupted by the compiler, the main thing that you do, you always start with compiling. So that way the compiler will catch any errors before you even start simulating. It'll point something out and be like, "Hey, this thing isn't defined. You should fix this before you try and simulate." Or something along the lines of that. Compiling is very important. Do not overlook it, because a lot of errors can be avoided simply just by compiling from the get-go. I know we had that a lot, Ryan, in like when we did it, and it was just because we just skipped over compiling. We would make a ton of changes and didn't compile, and we would be scratching our heads for hours. So
Basically, you can look at compiling as saving almost.
yeah,
So whenever you compile, it goes through all the code that you wrote and applies it.
yeah,
So if you don't compile before you simulate it, it's applying nothing.
yeah. So it's a really good way to put it. Just think of it like saving your progress. Obviously, you're not saving your progress, but to the compiler, it's basically giving it a fresh coat of paint and like, okay, here's your new code, and comb through it. So enough about compiling though, because once you compile, then you can do the fun stuff. You can actually go and simulate it. So we're currently on 17. Once you click the simulate, it'll pull up this here. Some main things to point out. Simulate as. This will change if you want your code to run as a blue or red sphere. Opponent. You have a few standard bots here that run on code that MIT and Zero Robotics have already made, but also you have select your or team code. So when you're making your code, if you want to compete against your friends and build off of each other's code, that option is there for you. But for now, we'll just make sure it's set to no opponent. But, and then maximum time, normally you don't really need to change this, but for the sake of example, we'll set this to 60 seconds and click simulate. And it'll say that it's running up here. And then once that running is done, it'll pop up over here and say that you can look at the results. It'll say simulation succeeded, view results. And all you have to do is click here, and it'll pull up this wide, big grid. This is a lot to take in. So I'll kind of just, before we start and see what happens, we'll kind of just look over a bit here. So these are your speeds. These are really good because sometimes you don't want to sit through the whole program itself. You kind of just want to speed things up. And these buttons let you do that. This completely restarts it back from normal. So if you want to watch your simulation again but don't want to drag this little bar over here, you can click this. These will let you zoom in and zoom out of the map. And this will take away the background. So it'll make it a lot easier to see your spears and what we're doing. Although, personally, I like to have it on because I like space. But anyways, for the sake of this, we'll just have it off. But in that case, go ahead. Oh, geez. We're going to go ahead and start it. And you'll see that our spear is slowly moving on over. You're going to want to keep your eyes up here because this will show you any type of stat that you want to know about in regards to your spear. So you can see that it's kind of moving pretty far off the map right now. But if you see right here, you can see that it's slowly approaching the value that we set before, which is good because that means our code is working correctly. See? It's staying right at that 1.3 value. So that's exactly what we wanted. Obviously, this isn't a good code in specs of the game, but for the tutorial's sake, it's just showing us how it works and all alongside that. So, with that though, can I do Control Tab? I can. Okay. So, normally you would close this, but since I'm in full screen, I'm just going to switch back over here. So, we're going to go ahead and return to the graphical editor. We're currently on page 21. So, now we're going to make a slight change to our program so we can kind of see the differences. So, we're going to change our y variable to -1.5. Compile. Don't forget to compile. Wait for that to finish. Simulate. Everything's all good. Wait for it to finish simulating. And kind of guess beforehand what it's going to do this time. And we'll take a quick look at the simulation here. You can see, we'll speed up a bit. You can see that it's starting to move on the negative side this time. So you can see that
I do want to point out, so when we were going over the different categories of the blocks in the IDE, we had touched on the debug. So debug is essentially just something that you can use within the code and it prints to the console. You mentioned the console earlier. I just wanted to say, if you see this white box at the bottom where you see by default the simulation is printing out all of this because it's sending back a out of bounds debug message. So this is the console where debug statements will print. Something just to keep in mind for later that I wanted to point out.
Yeah, that's a good point. So this is where you'll see all of your debug statements, kind of that I mentioned from beforehand. But I think it's just the limitations of the map itself. But it's kind of a bit on the shorter end of where it's supposed to be. But that's fine. We know that it moves already from beforehand. So in that case, there's one more thing to discuss, and that's taking a look at it in C code. So for any of you guys that like a challenge out there is an option to write all of your code in C code. So all keyboard, no blocks, and just going all at it. So we're currently on page 23. If you click this C code button up here, it'll actually pull up the C code and what it does. Now, if you select graphical in the beginning when you make your code, you won't be able to directly change any of the code here. But it's kind of good general knowledge to know what it's doing beforehand. I mean, it's always good to look at, right? I mean, it's kind of just good general knowledge to have, and if you kind of want to take that extra step and be like, I want to try, I think I can write this, then it is there for you in case you want to do it.
For the purpose of this program, you're mainly going to be using the graphical editor. But if you end up liking the subject of programming in general, C, so the language C, which is what this is in, is that text-based editor there. And that's what programming is at a higher and more professional level. So if you are interested in learning more about it, then swapping over and looking at the C code here would be something just to expose yourself and get a feel for what it looks like at a higher level and what is really going on behind the scenes.
Yes. Well, but with that, we've finished the first slide. So with that, you've successfully created and ran a program in the ZR IDE, and you've learned a bit about the variables and how they work. But as kind of a precursor to everything that you're going to be doing, the best way for you to learn is to just mess around with what you have and have fun. Just try and figure out, what if I do change this value all the way to the right? And kind of just playing around with it, because that's where the real fun comes with this. It's messing around, playing around, doing the best that you can. And yeah, any other comments, Ryan?
No, we've gotten through the whole first training module, and this is a good first start. It's really touching on the fundamentals of what programming is, what this program is, how the Zero Robotics IDE works. And with this knowledge, you're going to keep building more on it in future slides, future videos. Hope everyone enjoys the program, and we'll moving on from here.
Yep. All right, guys. Good luck out there and have fun.